Alright, welcome back everybody. In this video we're going to finish up example 2 from the Fundamental Theorem of Calculus Part 2 lesson. So we'll start with part E here. The integral from 0 to the natural logarithm of 5 of e to the x dx. So first we find the antiderivative of our integrand. The antiderivative of e to the x dx is just going to be e to the x. And we're going to evaluate that from 0 to the natural log of 5. So we've got e to the natural log of 5 minus e to the 0. And e to the natural log of 5 is going to be 5. And e to the 0 is 1. And so our value here is 4. Alright, on to part F. Integral from -1 to 1 of quantity t squared minus 2. So first I find my antiderivative. Antiderivative of t squared is 1/3 t to the third. Hello. Having some stylus issues. I really need to get some new good styluses. And the antiderivative of minus 2 is going to be minus 2t. And we're going to evaluate this from -1 to 1. So we've got 1/3 times 1 to the third minus 2 times 1 minus 1/3 times -1 to the third minus 2 times -1. And so that gives me 1/3 minus 2 minus the quantity -1/3 plus 2. And so we end up with -5/3 minus 5/3. And so our value for our definite integral will be -10/3. Or for those of you who like the decimals, -3.3 repeating. Alright. Alright. Part G. The antiderivative of 1 over the square root of 1 minus x squared dx. So first we find the antiderivative. What do we take the derivative of to get 1 over the square root of 1 minus x squared? And that is our derivative rule for the arc sine. So it's going to be sine inverse of x, evaluated from -1 to 1. So we've got sine inverse of 1 minus sine inverse of -1. And the sine inverse of 1 is going to be pi over 2. The sine inverse of -1 is going to be negative pi over 2. And so we end up with pi for the value of our definite integral. Alright, part H. The integral from 4 to 9 of the quantity 1 minus the square root of u over the square root of u du. Now this one, when I look at it, I'm like, do I know a rule that leads to this? And I don't. But what I can do, since I have just a single term in the denominator, is I can change this into the integral from 4 to 9, and I can divide the square root of u through both terms. So I've got 1 over the square root of u minus the square root of u over the square root of u. And so really I'm taking the integral from 4 to 9 of u to the -1/2 minus 1. Alright, the antiderivative of u to the -1/2 is 2u to the 1/2, or 2 times the square root of u. And the antiderivative of 1 is just going to be u. So this turns into the quantity 2 square root of u minus u when we take the antiderivative. And now I'm going to evaluate. So I've got 2 times the square root of 9 minus 9 minus 2 times the square root of 4 minus 4. And let's see, that's going to be 2 root 9 is 6. 6 minus 9 is negative 3. And 2 root 4 is 4. And so we end up with negative 3 as the value of our definite integral for that function. All right, that's it for the Fundamental Theorem of Calculus Part 2, the integral evaluation theorem. Basically, I hope you understand all we're doing is finding the antiderivative of our integrand and then substituting in the limits of integration and evaluating them and then subtracting the value for the upper limit of integration minus the value for the lower limit of integration. All right, see you guys next time. Have a great rest of your day.